Good morning, everyone. Myself, Monica Nansupriya, Assistant Professor in Department of Electrical and Electronics Engineering. In this semester, I'm handling basic electrical and electronics engineering, subject code W25C01 in the regulation 2025. So today we are going to study the semiconductor device used in modern electronics, that is the MOSFET, which stands for the metal oxide semiconductor field effect transistor. In previous class, we studied the bipolar junction transistor. Today, we will learn MOSFETs, which are more widely used in modern electronic systems, microprocessor, memory chips, and power electronics. So, at the end of the session, the student may able to know what is MOSFET and the construction, working principle. So, identify the terminals, how the characteristics is, and the application also. So, first, what is MOSFET? The MOSFET stands for metal oxide semiconductor field effect transistor. So it is a semiconductor device used for amplification and switching. So why MOSFET is important? Today, billions of MOSFETs present inside the mobile phones, computers, laptops, microprocessors, and memory chips. So the MOSFETs have become the foundation of modern electronics because they consume very little power and occupy very little space also. So the transistors are used in everyday life. Where the transistors are used in everyday life? Yes, it's a smartphone, computers, TVs, and chargers. So next one is the types of transistor. Here the types of MOSFET is N-channel MOSFET and P-channel MOSFET. So in N-channel MOSFET, the current conduction occurs through the electron. So the advantages are the faster operation, higher mobility, and it was most commonly used. Next one is the P-channel MOSFET. Is the current conduction occurs through the holes. So N-channel is the current conduction occurs through the electrons, and in the P-channel is current conduction occurs through the holes. So the advantages is simpler higher side switching in some circuits. So in comparison, N channel is N channel uses electron, whereas the P channel uses holes. The N channel is faster and the P channel is slower compared to the N channel. And the N channel have a lower resistance and the P channel have a higher resistance. So it is widely used and the P channel is less common. So the electron move faster than the hole, therefore the N channel MOSFETs are generally preferred. This is the symbol for the N channel and P channel MOSFET, the gate, drain, and source. And in P channel also the gate, drain, and source. In this N channel, the arrow is inward to the gate, and in P channel, the arrow is outward to the source. Okay. Next, the importance of MOSFET. What is the important? Is one of the most used electronic device and it's a very small size. So the millions and billions of MOSFETs can be fabricated in a single IC. So it consumes a less power. So the gate draws almost no current. So it have the high switching speed and it's suitable for the digital electronics, high reliability. So modern CPUs contain billions of MOSFET transistors. And the MOSFET terminals, this is nothing but we have the see no this the MOSFET terminals have four terminals: source, gate, drain, and the body. This is the body. Okay, so this is the terminal. For function of each terminal is source. What is source will do? The source supplies the charge carriers. Think of it. So this is the starting point. Okay, so what is the drain will do? The drain collect the charge carrier. This is the supplies the charge carriers and the drain collect the charge carrier. So this is the destination. And the gate, it's control the current flow. So it acts as a switch. Then the body, it's substation, the region of MOSFET, usually connected internally to the source. So although MOSFET has a four terminals, it is usually treated as a three-terminal device because the body is connected to the source. Then why the MOSFET is called the field effect transistor? Why the MOSFET is called the field effect transistor? The term field effect means the current flowing through the device is controlled by an electric field. Unlike BJTs, BJTs are current control devices and the MOSFETs are voltage control devices. So the small gate voltage can control the large current flowing through the drain and the source. So this makes the MOSFET more efficient. The construction is observe the MOSFET structure carefully. The main components is source region, drain region, and the gate terminal. So the source region is highly doped semiconductor region. The drain is another highly doped semiconductor region, and the gate is placed above the channel. So the channel based above the channel. So the oxide layer, that is a very thin layer. This is the oxide layer. It's a very thin insulating layer. So usually silicon dioxide, that is SiO2, is used for the oxide layer. And the substrate body forms the base. This is the substrate. This forms the base semiconductor material. So the important point is the gate is insulated from the semiconductor by the oxide layer. Because of this insulation, almost no current enters to the gate. By using these oxide insulator here, so there is no current enters the gate. So this is the major reason of the MOSFET extremely have the high input impedance. So this is the construction, and the working is the MOSFET works by controlling the conductivity of a channel between the source and drain. So the gate voltage determines whether the channel exists or not. If the gate voltage only determines how this only decides whether the channel is having a current or not. So the simple analogy is imagine a water pipe. So source is the water tank and the drain is the outlet. So gate is the wall. Okay. So by opening or closing the wall, it means by opening or closing the gate, we can control the water flow. Okay. So if we opening or closing the wall, we can control the water flow. Similarly, the gate voltage controls the current flow. So this is the working of this MOSFET. And the channel formation is the region between the source and drain is called the channel. So channel may be conductive or non-conductive depending upon the gate voltage. If the gate voltage is open, it is a non-conductive. If gate voltage is closed, then it is a conductive. So then the key concept is no gate voltage, no channel, and the no gate voltage, sufficient gate voltage means channel form the current begins to flow. So the positive gate voltage also consider the N channel MOSFET when a positive voltage is applied to the gate. So the positive gate attracts the electrons. So the next one, the holes are repelled away from the surface and the depletion region forms. So the electron gather near the oxide layer. So the conductive channel is created. Now the current flow between the source and drain. The conductive channel, whenever the conductive channel is created, there is a gate voltage is present. The current can flow between the source and drain. Then next one is the depletion region. So when the holes move away from the surface, the region lacking the free charge carriers is created. So the region is called the depletion region. The characteristic is poor conductor forms before the channel creation. So the current flow through the channel. Once the channel forms, the electron travels from source to drain. When drain source voltage is applied, the current starts flowing. So the important relation is the higher gate voltage having the more electrons and the wider channel having a larger current. So the gate controls the current flow. Then what is the negative gate voltage? When a negative gate voltage is applied, the holes accumulate beneath the oxide layer. So the whole channel forms. So the current conduction occurs through the holes. The positive gate voltage favors the N-channel conduction. So these are the negative gate voltage favors for the P-channel conduction. Then one is the characteristics of a MOSFET having the high impedance. Here, the MOSFET possesses the extremely high input impedance. So input impedance may range from the mega ohms. Okay, so input impedance may range from the mega ohms to the giga ohms. So the gate is insulated by an oxide layer. A very little current draw from the input source. So this reduces the power consumption, and this is a voltage control device. Unlike it having a BJT, BJT is a current control and the MOSFET is a voltage control. So the advantage is less power is need to control the device. Therefore, the MOSFETs are more efficient. Next one is the fast switching speed, and the MOSFETs can switch on and off very quickly. So the application is the switching power supplies, digital circuits, and the computer process. And having the low on resistance, that is the MOSFET is fully on, the drain source resistance becomes very small. So the benefits is less power loss, less heat generation, higher efficiency. And the next one is also the thermal stability. Thermal stability means the device can operate effectively even when the temperature changes. That is the advantage. Having the better reliability, longer lifespan, reduce the risk of thermal runaway. So the industrial application, mostly MOSFETs are used for suitable for the industrial applications. Then it's the unipolar device. In MOSFET is called the unipolar device because only one type of carrier participation in conduction. Whereas in BJT there is a both type of carrier starting conduction. But in MOSFET we are having the unipolar. That is the N channel MOSFET uses the electron only and the P channel MOSFET uses the holes only. By the comparison with BJT, BJT uses electrons and holes. So BJT is a bipolar. MOSFET uses only one charge carrier. So MOSFET is a unipolar. Then the three-terminal device having the gate, source, and drain. And the application is also MOSFETs are widely used microprocessor, logic gates, memory circuits, amplifiers, inverters, UPS. The numerous number of applications are there. So, in today's topic, we are study about what the MOSFET stands for, important points of the MOSFET. That is the four terminal having the including body. We are discussed about the four terminals, and the MOSFET is a voltage control device having the high input impedance, fast switching speed, low power consumption, and it's a unipolar device. And the applications are also we have seen. These are the topics covered under the MOSFET, and these are the references. Thank you.